How do fossils come out of the literal dirt and end up displayed in such exquisite, breathtaking detail? The journey from the earth beneath our feet to the magnificent displays we know and love is not an easy one. I'm your mental curator, Johnny Hemberger, and you're listening to the HMNS Beyond Bones Podcast. Available here and in virtually any podcast app. Just look for the purple color scheme. The subject today is as painstaking and filthy as it is spellbinding and beautiful. Colin Diggins is our paleontology laboratory manager here at the Houston Museum of Natural Science and will help us sift through the science of bringing such astonishing fossils to life. Colin, where are we today?
So right now we are in the Still Life After Death gallery in the Morean Hall of Paleontology, specifically standing in front of a fossil garfish just here from the Green River formations. This is about 55 million years old. Beautiful thing about this is you can see all those armored scales still articulated, still laying exactly as they were on the animal when it was alive. It's also got these wonderfully articulated fins just here, which are made up of all these individual, absolutely minuscule little bones that are probably difficult to see unless you get a very, very tight, close look in at that. And this here is just a really spectacular example of what we do in our lab over in the corner of the Morean Hall of Paleontology, something we call fossil preparation, which is essentially how we go about uncovering these from the rock that's been hiding them for millions of years.
So what is the significance of this? You were telling me off camera that this is a good piece to start with when discussing fossil preparation. That is the topic of this podcast, fossil prep. This is a good place to start. Why?
Well, for a few good reasons, honestly. We really do love working on this Green River formation material for a number of different reasons. One is that there's this obvious beautiful contrast between the fossil itself and the rock around it. And the other is, of course, also the preservation too, right? So fossils, usually these animals are getting buried after, undergoing some degree of decomposition, of getting, shifted by predators coming along and scavenging things, decomposition, water moving parts of the skeletons as they kind of disarticulate or fall apart. So this is a beautifully articulated version where you can see the entire animal essentially as it was when it was alive as well. So it's just a beautiful specimen to get a visual picture of the animal. And of course it also allows us to relate it back to its living relatives today as well, the other garfish that are still present in the bayous in Houston.
Right.
And these are, animals that were around for a really long period of time as well. If you're digging in the Cretaceous Hell Creek Formation, things like disarticulated gar scales are very common finds. And obviously, like I said, they're still present today. So throughout time, as you're digging in these rock formations, these gar scales are pretty common things to find.
In the United States, where's the Green River?
So it's a pretty large formation that's kind of spread out across southwest Wyoming all the way on over into Colorado and Utah. It represents a series of really massive lakes at any time, 1 to 4 really big lakes that covered pretty massive areas. And the area in and around the little town of Kemmerer in southwest Wyoming, there's a Fossil Butte National Monument and a number of other quarries nearby as well that turn up a lot of really spectacular fossils like this one here.
So one of the fascinating things about this and why we chose it to discuss fossil prep and whatnot are all these scales. You can look at this specimen specifically, and if you want to appreciate, there's a lot of specimens that help you appreciate fossil prep, but the amount of time and dedication, all these scales to bring out, you brought out, or whoever
this was not my prep.
Whoever prepped this, the meticulous nature of using the air scribes and using all the various tools and abrasive tools to not destroy the specimen,
absolutely,
but also bring out all this contrast and detail in the specimen. Can you speak to a little bit about, how you go about making sure you can see every single one of these scales?
Oh, absolutely. Yeah, I always feel like I have to mention that this probably represents hundreds, if not thousands of hours of an individual's time.
Right.
Not only do you have to get in between each one of these little cracks and gaps between the fossils where they sort of sit and overlap. There's a lot of three-dimensionality to this piece. It may look very flat in the image, but these scales are not just sitting there all perfectly on top of one another. In the few spots here, they do kind of shift and alter their orientation to each other. And going through, we always say with these Green River Formation fossils, they're relatively predictable. You can get an idea, even when it's sitting underneath the surface, from the way that the rock is laying over the top, more or less what you're going to find in there, but you never know 100% what you're going to find.
Right.
And as detailed and difficult as getting in and around all these scales and the small bones in the skull is, the fins are where the work really becomes truly exceptionally mind-numbingly difficult.
Right.
The fossil bones there are so small, so delicate, so fragile that you can destroy them utterly if you are not careful.
Right.
With these fins, the last little tiny bones often do, even just from sitting on the bottom, will kind of disarticulate and float away from each other. So it becomes a lot less regular and a lot less predictable the further out along those fins that you go.
One thing I wanted to mention here, Colin, is if you are listening to the podcast, you should subscribe to our YouTube channel where you can see the podcast. So I'm going to do these tight B-roll shots where you can see this is a 3-dimensional creature right here. This is a 3-dimensional fossil. You might think, like Colin mentioned, that it's just a flat, maybe kind of drawing on a paper. No, it is not. Where we're standing at an angle here. You can see from our perspective that it is that this fish has girth. The girth of the animal is still preserved here, and I will show that on the YouTube version. So if you're just listening to the Beyond Bones podcast audio version, check the link in the description so you can see the video version as well, because that's where the magic is at with how we're describing this in the meticulous nature of fossil prep. I'll get in right on these fins so you can see. Yeah, so I was thinking of the scales, just the meticulous nature of the scales, but then you mentioned that these fins, these are very, I would say almost like hair-like structures.
Once you get down to the end, especially on some of the smaller fish, when I've been prepping them, I have literally taken a loose hair and laid it on the slab next to the ends of those little fin rays. Same diameter.
You might have some hair to spare versus me, who doesn't have anything to.
Well, you can spare. The beard hair will work.
The beard hair is exactly right.
In any case, but no, they get insanely delicate, and it is very, very difficult prep work.
So I want to move over to our specimen just behind us. I'm going to move the camera here. For listening to the podcast, watching the video, it's going to be instant. We move the camera over to the frigate bird, and that's what we're going to talk about right now. Colin, you mentioned off camera that in fossil prep up until probably fairly recently in history, we weren't finding skin of dinosaurs or extinct creatures, not a whole lot like you might expect, because we see skin now. And there's a reason why we are finding more and more skin. Why is that?
Absolutely, yeah. So, of course, fossils has a history of life on the planet Earth, sort of all life through prehistory. We tend to find things that are biased towards preservation. It's kind of a fancy way of saying it, right? Mm-hmm. We tend to find things that fossilize well the most. So hard bits of the body, like bones, fossilize really well. Shells, those hard structures that animals are building to anchor muscles and things like that are gonna tend to be preserved more often. And because we were finding them so often, the assumption was that things like soft tissues, skin, hair, feathers, organs isn't going to fossilize. And that is the case most of the time. Preservation doesn't tend to favor things like that being, surviving. Mm-hmm. These things tend to decompose very quickly. The chemistry of the rock can also just obliterate any possibility of those things surviving. But it's one of those things that, accidental discoveries throughout history have occasionally turned up these extraordinary examples of preservation. So, there were some early historical examples of dinosaur skin popping up, but it wasn't until we realized that it was definitely a possibility, that this is something that does happen on occasion, that people started to pay more attention, prep much more slower and much more carefully. If you think about something on the size of a dinosaur, this is a huge animal. It takes a lot of effort to remove all those bones from the rock, to reassemble and to repair them, to then mount them in an exhibit and put them on display, or even just to house them properly in a collection on shelves somewhere where they can be studied and researched. So it's an insanely time-consuming and also, expensive process in many regards. So there was an incentive, you might have said, to just go as quickly as possible and get things done. So there wasn't really a sense that because there wasn't really any hope that skin would show up, and it would just be insane to spend hundreds of hours digging through the rock looking for something that was never going to be there anyway.
Grain by grain,
you wouldn't
even.
want to spend the time doing it. It'd be a complete waste of effort and money, and so many reasons why you wouldn't look for it. But because we know now that there is the opportunity for it to show up, and that even using like alternate sources of lighting like UV, you can turn up things that aren't even necessarily visible with the naked eye, people are going a lot slower and being a lot more careful with the prep. And of course, then the question becomes even, should you prep it at all? Because you never know, 30, 50, 100, 200 years down the line, is there a possibility that new technologies are going to show us details to these fossils that if we had prepped them now, we would utterly destroy?
That is fascinating.
And, there is every likelihood, every possibility that some of the fossils that we've prepped historically, in fact, I would say it's almost certain that we've destroyed information and removed details that would later on we might have been able to preserve and learn a lot from. But of course, the science doesn't advance if you don't take the time to try and learn from the material that you have right now. And of course, there's always a possibility of new fossils coming up in the future as well. So it's a bit of a balancing act. We always say that in our lab, the best thing to do is always to under-prepare rather than over-prepare. And that's not in the sense of getting ready, but just in terms of preparing the fossils. It's better to remove too little rock than to remove too much and risk damaging the specimen or potentially removing information that might be absolutely critical to our understanding of these animals in the future. It's part of the reason why right now we're working on a huge block of rock in our lab that was found alongside of our T-Rex. And it doesn't contain any T-Rex bones to our knowledge, but it does contain 2 turtles that were found alongside that T-Rex. And we are trying to prep that as insanely carefully and detailed and as slowly as possible to look for not just those turtles, but evidence of plants, even potentially pollen grains or microscopic diatoms from the water, and also to look for maybe whether there is any skin associated with these turtles to see whether that could have been preserved from these animals. Because some folks have proposed that the skin on our T-Rex is actually from the turtles themselves. So one way to prove that is to find skin on the turtles that looks totally different, or maybe not find any skin with the turtles at all, at least goes to help strengthening that argument. But it's again, if you're not careful and looking for it on a very detailed level, if we were just prepping to try and get those turtles out, we might potentially blow through fossil skin and never see it at all.
Let's get back to the frigate bird specifically here.
Yeah.
As a fossil prepper, as somebody who's prepped fossils, once you start seeing the evidence, oh, this might be a feather here, or this might be some skin here, this might be some preserved soft tissue or preserved like hair, feathers, and whatnot. What do you do? Do you switch tools? Do you stop? What is the process at that point when you found something that is more delicate than bone?
Oh yeah, you absolutely do have to switch out so the sorts of tools that you're using, and these sorts of things like feathers or hairs are such delicate structures to begin with that they're preserved as nothing more than just a carbon film in the rock. This is literally microns or molecules in thickness, and if you're not careful with those tools, it will absolutely destroy it. Now, hopefully, because these started out as 2 different materials, as mud and the keratin of the feathers, there should hopefully be some separation or natural release along that plane, but you can go right through it in a heartbeat if you're not being very delicate. So the tiniest, finest tools are the sorts of things you're going to need to use for this. The needles are going to be just so itty bitty that they're very easy to bend, right? The rock will very almost break the needle before you can prep it. They use a lot of air abrasions. That's little teeny tiny powders in a very, very fine, very detailed sandblaster, essentially, to very carefully sort of erode the rock away. And of course, the other thing that is absolutely critical to prep like this is what we call consolidants. It's kind of like a very thin glue that you may dip into the rock to help to solidify and strengthen these specific layers so that you're not just going to immediately remove it and it will hopefully stay and separate a little bit easier. And then you may even have to selectively remove that glue in certain areas to make it easier for yourself. I personally have not prepped any feather material from the Green River Formation. I don't really want to because I'm fairly certain I would destroy it. I've sunk hundreds of hours into preparation of Green River fossils, and I am nowhere near prepared yet to tackle a project like this. No, this is somebody who is a master of their trade, who spent a lifetime learning fossil prep, usually.
I think one of the most fascinating things, because a few years ago I was privileged enough to go on a dig in the Walk Quarry in Wyoming, and being a complete layman to it, I have never dug for fossils. You'd think that you just go in there with shovels in a bobcat and that is certainly true. You do remove a lot of material. What removes the most material, here's what was the shocker for me, was most of the work is done with brushes and scalpels, basically.
Yep.
Very fine, delicate work. And what I noticed is that, when I saw the front end loader and the wall quarry, it's like, oh, this is just to get to the bones. And perhaps that's true maybe at the start of things. But what really the Bobcat was used is, you'd be surprised how much matrix is created by just brushes and just scalpels.
Absolutely.
And you get to a point, you bring it to a lab for further preparation. It took me so long to say that word.
That's all right. You nailed it. No, so the lab is almost in like microcosm, the same sort of thing in the field. You're just progressively using smaller and smaller tools the closer and closer you get to the fossil.
Right.
That Bobcat, as you say, is very useful for making sure that all of the stuff you're removing doesn't pile you under. All that overburden, the spoil pile, has to go somewhere. But sometimes there'll be lots of layers of rock well above it. You have to quarry away beforehand, but you'll stop several feet above or several meters above where the fossils are at with something like a heavy equipment, because you're worried about damaging those fossils and you really don't want to hit them. You might use hand tools at that point, like a shovel, to get closer and closer. But as you said, in the quarry, just even getting to the point where you're going to build maybe even a field jacket to take it back to a lab, you have to use smaller and smaller tools, down to even like dental picks or surgical scalpels, X-Acto blades. And then in the lab, we might start out with those same tools, and we're going to work down to finer and finer, smaller and smaller detailed tools, again, as we get closer and closer to the actual surface of the fossil. And that's also what's fascinating to me, is people might think, oh, you find a bone, you get the bones out of the dirt and you bring them to the lab. Well, you don't typically, that's not all the time. I would say what I witnessed digging for fossils myself was, you'd find this big femur sticking, or this disarticulated skeleton. Yep. And you're not picking out the individual vertebrae and whatnot from that pile. You say, all right, this is the perimeter of where the specimen is. Yep. We're going to take out this entire chunk of earth and the bore holes underneath it, so that they can put like straps down or 2x4s to hoist it out with a forklift or by helicopter or whatever they're going to do. Whatever tools they have available. And you case it, you prep it in the field for shipment to the lab. How do you prep it in the field for shipment in the lab? Plaster and all that. Yeah, so like the jacketing process is something that's been done for over 100 years now. It started out as, lots of burlap and plaster slapped right onto the rock, and then they were hauling it out with horse teams and carriages, essentially. That's how a lot of the specimens, say, in the American Museum of Natural History in New York were quarried. These days, it's become a little bit more advanced because we can use heavy machinery and things, and the materials have changed somewhat, and we want to make sure that we got some layer to keep all that plaster from getting directly on the rock. But in order to take these out in any sort of a way that is going to protect them and save them, to get them back to a lab where they can be cleaned in a very detailed and a careful manner, which you can never really do given the limitations out in the weather, in the field, and with the wildlife potentially there as well, from poisonous snakes to stampeding buffalo back in the day. You just don't really have the hundreds of hours to spend there carefully cleaning the bones on a tiny little scale. You have to take the blocks of rock in those massive field jackets where they're basically encased in a cast, not unlike you would a broken arm or a leg. And that's where the work in the lab really gets started, is just starting by opening those jackets and looking at what's in them and trying to gradually uncover those individual elements, but doing it in a way that is so detailed that you can preserve all of the information that fossil potentially has to tell you, which you just can't get just pulling them out of the ground in the field. And part of that is, again, as you say, taking the jackets where all the specimen is still together, where you can remove big blocks that show where these bones were in position to each other. It tells us a lot about not just that individual animal, but how it comes to rest in that rock. It's story of burial. Exactly. That the context in which this lived and very certainly died is very important. You mentioned that earlier in a previous information. Exactly. You mentioned that in a previous podcast where for quite a while, it was more about just digging the bones out and putting them together and just seeing the animal. Yep, which is important. Which is important, but increasingly, scientists have become more aware of and more in tune to is the context in which they live. This puzzle. Okay, we have T-Rex, and at first we thought it stood up on its back tail like a kangaroo or something like that. But you start learning more about not only about the animal and how it really stood up. You find its teeth in other animal bone beds. Oh, that's how we know relationships. Exactly. That's how we know T-Rex fed on these edmontosaurs in there. So you start building this picture, this portrait of how this animal actually lived and how it died.
And speaking to how it died, a point I wanted to make earlier is that Mother Nature gives, Mother Nature takes away.
Indeed.
So in the Wa Quarry, for instance, the Black Hills uplift, these animals died in those lakes, in these oxbow lakes. There's a lot of water, there's a lot of palm tree. Like you wouldn't think of palms and things being in South Dakota, but a long time ago, it was a much different climate, much different atmosphere, much different ecosystem in which these creatures died.
Absolutely.
So they get buried for millions of years, and then the Black Hills uplift plate tectonics starts pushing them up. I like to say Mother Nature does 99% of the excavation.
Work of excavation, you're absolutely right.
But also, so it did the work of preserving, it did the work of excavating, but once it sees the light of day,
it also immediately begins destroying it, yes.
Clock's ticking. So that's why we have to take these, this frigate bird, it probably wasn't taken out of the field and just this thinly sliced layer. It was probably a lot more, certainly there was more on top of it and everything like that. And it's once you discovered it was there, clock's ticking, get it somewhere, a controlled environment where you can start working on it.
Yeah. Then this is really interesting too. There's a few points that I want to mention there that you brought up. Sort of one thing about learning about these environments and the interactions between these animals too that's really quite interesting is that, and the changes in the environment, is the Green River Formation, this frigate bird, is part of a really beautiful snapshot of those environments. It does such a great job of preserving not just these individual animals, but the whole environment that we can see that, yes, now, modern day Wyoming may not be all that wet and it may not be all that tropical or subtropical. We still see palm trees in that area at the times. It was a very different sort of environment, even though many of these animals are still alive today, like the frigate bird, which can be seen down in Galveston, not as far outside of Houston today.
Right.
But then also talking about sort of the quarrying aspect of these, the Green River Formation is really kind of fascinating for that reason as well, because these have all been uplifted onto massive buttes. So these, even though these were bottoms of ancient kind of deep lakes 50 plus million years ago, they're now on the tops of essentially mountains.
Right.
And they just slowly weather and the rock will crack naturally and separate sort of almost in plates because these are laid down in very fine sort of thin layers. Mm-hmm. So this was actually taken out as one big plate that, well, not very thick. It was kind of thin relative to what we think of as big field jackets that say something like the Wa Quarry. It still obviously, had rock completely covering the bird here, which was beautiful because they just split the layers of rock before they can split naturally. True. And as they do that, they can see these sitting just underneath the surface, essentially as lumps. You see a lot of little lumps on here from the high angle of the lighting, which are things like little snails or gastropods. Some of these may even be coprolites, fossil poop from things like the crocodiles, essentially, that were swimming around in these ancient lakes as well. And if you were to just allow this butte to weather away naturally, it would actually cut them along the edges and would be gradually eroding away parts of these birds. And very often when we find these fossils, it's because nature has already gotten to them and begun that work of excavation. It has already begun destroying the fossil, and we've just arrived in that right timing to be able to say, this is being eroded, this is being destroyed. If we get into this rock, we can pull it out now and we can potentially rescue it and prep it in a lab where we're going to be able to see all these bits as they were more or less on the animal rather than just as broken fragments that no one will ever be able to identify.
And to that point also, fossilized bones are rock at that point. And they aren't in and of itself it's not a Fabergé egg or something that's going to just crumble in your hands. When it's millions of years old like that, when it's fossilized and mineralized for millions of years old, it's not going to fall apart in your hand. A mammoth bone could. A mammoth bone actually, since they died out thousands of years ago, that can be a very, due to its stage, you can speak to this, due to its stage in fossilization, I've heard that as soon as, depending on the climate in which it's found, like in Texas and whatnot, that as soon as the bone touches the air, it starts to create fissures and it starts to kind of fall apart. Can you speak to that
absolutely.
About recent fossils?
Even I do want to make one point is that even with 280 plus million year old fossils or 60 plus million year old fossils, that even though they're really well mineralized, sometimes they can crumble in your hands. Even though they are very hard, sometimes they can still be incredibly brittle and very fragile.
True.
Like we'd never want to try and take these out.
No.
If you did, they would absolutely snap, crumble, crack, fall to pieces. And that's why we don't allow everybody to come in and handle all of our fossils on display, because even though they're very hard and they're usually very stable, very resistant, they're still very fragile. But modern, or more recent fossils, I should say, those from the Pleistocene, those from the Ice Age, that are actually the sort we find right around here in Houston, are often not completely mineralized. They've undergone some degree, perhaps, of absorbing minerals from the surrounding rock, but they're just not done cooking, so to speak. Sometimes they can even undergo periods where they will partially mineralize, but then if they're exposed to slightly acidic water or some other change in their environment, they might begin to demineralize. I know of a site here in Texas out near the Georgetown area where they've got a mammoth or a mastodon basically in the ground there, but it's the consistency of wet toilet paper, and trying to get that out would just actively destroy it. And oftentimes it is due to those changes in moisture level. These things may be very stable in the ground, but as soon as you pull them out, the changes in the moisture may start the sort of the decay process all over again. They might just begin to completely start falling apart. And it may be that if you leave that buried in the ground in 6 million, 8 million years, it may mineralize and preserve, or it may completely demineralize, decompose, and you would not see any evidence of it at all.
Right. I've also heard that, we work in a museum. I get to be here basically every day and be around fossils every day and a lot of other cool stuff in the museum, obviously. But someone who is so close to fossils and has access to the Green River room here and just be around fossils, you think that they're everywhere and that they're prevalent and that they're not rare. But the fact is that fossilization, for something to fossilize over hundreds of millions of years, tens of millions of years, that's a very precise, perfect set of circumstances that help preserve this fossil. Case in point, I've heard it theorized, T-Rex, Tyrannosaurus Rex, that, how many T-Rexes would have lived from the time they first appeared in the evolutionary track to the end? It was like a billion or maybe a billion or so T-Rexes over millions of years, something like that. Or there's 7 billion human beings or whatever. But over time, we haven't found a billion T-Rexes.
No, we're only ever going to find a tiny fraction of the ones that ever lived on the planet at all.
Because the fact is, most of them died and their bones deteriorated and they did not mineralize. They got changed around and mixed in with things. They become like the sand on the beach and they're gone.
Things,
So that's what happened to the lion's share of the fossilized animals we find. So that's why it's still, even though we're close to it and we think that fossils are they are everywhere. But we found, several T-Rexes out of theoretical, a billion T-Rexes or whatever the number actually was.
Yeah.
That fossilization is rare. And to preserve a frigate bird, in this case, like this, and especially still with the feathers mostly intact, reasonably intact, is like hitting the lottery.
Absolutely.
As far as the evolution,
no
as
doubt.
far as fossilization is concerned.
Oh, very true. No, yeah. So there's a few things that go on that contribute to that as well. I mean, one is sort of the proportion in the environment, right? If you think about something like T-Rex, a large-bodied predator tends to be, very few and far between on modern environments. There tends to be a lot more large herbivores or things for those predators to eat in order for them to survive. So just in terms of proportion, you see different sorts of animals being preserved one way or the other. And then, of course, it's sorts of environments that they live in. This frigate bird just happened to die and fall into the lake where it was going to be preserved. But typically, it's more likely to happen with a bird like a frigate bird because they do spend time around water, but they don't necessarily live in the water. They're not necessarily a water bird in the sense of like a duck, perhaps. So the odds of one of these being preserved in that environment is not super high, although it's more likely. And then this is more likely to be preserved in this sort of formation just because it had all those right circumstances line up for that sort of thing to happen. But even in that formation, the likelihood of coming across one of these fossils is insanely low. So these are those lottery numbers, just the 1 in 10 million, 1 in 20 billion sort of likelihood of ever finding something like this.
Right. And the other thing is, you mentioned T-Rex and predating on other herbivores and whatnot, is the circumstances of their death and what happens almost immediately after their death is critical.
Largely determine what happens to them.
Most animals got scavenged on. They died. They didn't die by a river. They didn't die in the mud. They didn't die and then be immediately covered by a landslide or something like that. Most animals died and just got picked apart within probably days of after they died. And
or if not in days, and over a matter of years. Because of course, not only are there these big predators coming along and taking chunks off the animal and maybe chomping on the bones and chewing those down, but then of course there's the bacteria that are degrading the flesh. They will eventually decompose the bones even over time. So it's one of those things that even a fossil that isn't necessarily immediately scavenged by larger other animals will just gradually break down in a way that even just from the weathering of the bones sitting out on the surface from the rain and from the sun just gradually break down into things that are completely unrecognizable as the animals they were once a part of.
That's the thing too, the sun. If you're sitting out in the sun is just gonna bleach you
UV
and
radiation.
radiate you, and
Yep,
it's gonna
absolutely.
bad news bears. So yeah, every time you see a fossil, not just this frigate bird or the gar behind us or any of the other awesome specimens here in the Green River room, the still life after death
Gallery.
Green River Fossil Gallery. Every fossil you see is special. It has survived this amount of time, this insane amount of time, and all against all the odds, and it has survived, and we found it, and we're able to preserve it for everybody to see. That's one thing I wish people would take away more is, I did a video recently about, you see one fossil and you just, every fossil's a fossil, a leg is a leg, a jaw is a jaw. But if you look closer, like on our Gorgosaurus, you see the bone cancer and you see,
all the
Ryan
details.
was telling me that it probably had brain cancer in its brain case. You don't notice that stuff just breezing through.
Absolutely.
Fossils are special. Even if you've seen a bunch of fossils at different museums, fossils themselves are very special things. And you can learn an awful lot about the history of the Earth, including our place in it.
Absolutely.
I believe.
Yeah, it's just one thing I would really love to mention is that there's a lot of discussion and controversy these days over private ownership and the price and purchasing of fossils. And it's one of those things that one thing we always love to mention is that these, at least as far as paleontologists and researchers are concerned, are absolutely priceless.
Right.
Because each one tells a story, not just about the individual animal, but about the ecosystem and the species and the story of life on the planet as a whole.
Yeah.
Each fossil, while some are very common, very easily found, and are maybe not as important or as precious individually, they all go to tell a story, and that is to us just really the beauty of these things.
Thank you so much for listening to the HMNS Beyond Bones podcast. If you enjoyed this episode, we truly appreciate if you'd consider subscribing and rating us in your favorite podcast app. It would also be amazing if you'd consider sharing the HMNS Beyond Bones podcast with your friends and family. Just pop it up there on Facebook. You can also email us at podcasts@hmns.org. Be sure to check the description for any links and other goodies. But with that, I've been your mental curator, Johnny Hemberger, reminding you to come visit us at the Houston Museum of Natural Science. And until we meet again, stay safe and stay curious.